All right, here are a couple more questions about the hominin species and some of these trends. So this one is on page 18. So a hominin species, Homo floresiensis, was identified from fossils found on an isolated Indonesian island. These fossils were dated to be 18,000 years old. So the adult skull of this upright bipedal hominin had a cranial volume of less than 1/3 of the average cranial volume of a modern human. So they had a very small brain. It had harder, thicker eyebrow ridges than Homo sapiens, a sharply sloping forehead, and no chin. Really weird. I don't know how you have a really sharply sloping forehead and no chin. It must be like. Homo floresiensis was just over 1 meter tall, and their arm to leg ratio was slightly larger than modern humans. So what do all those things indicate to me? That indicates maybe they were an older root or came from a less recent common ancestor than modern humans. They weighed approximately 16 kilos. The fossils were found in sediment that also contained stone tools. So they had tools, fireplaces for cooking. The fireplaces contained the burnt bones of animals, each weighing more than 350 kilograms. So the stone tools included blades, spearheads, cutting and chopping tools. So I'd like you to pause, read through these answers and see what the evidence above can support the current theories. I'm going to go through in 3, 2, 1. All right, so the above evidence. The very small stature of Homo floresiensis is unexpected in a species that is geographically isolated on a small island. Do you think being geographically isolated has any necessarily influence on that being? There's no unexpectedness about that. So floresiensis was a species that showed considerable social cooperation and methods for passing on knowledge. Is there any evidence there that suggests that they might have needed social cooperation? Yeah. Let's go maybe. The sloping forehead and absence of chin of members of Homo floresiensis species suggests that they were members of the first migrations of hominins into Australia over 50,000 years ago. Now these guys, we found them, they said they were 18,000 years ago. They said this happened 50,000 years ago. The hominins that are in Australia are definitely Homo sapiens. So no, that's not the case. At that time, the hominins that were in Australia were definitely Homo sapiens. The skull shape and size of Homo floresiensis suggests a close relationship to the Homo neanderthalensis species. So we said the Neanderthals were short, but Neanderthals have a really big brain. So the skull shape and size says no, that's not the case. So what is it that allows them to show social cooperation in this question? I'm going to focus back here on this little bit here that says they found the burnt bones of animals with each weighing more than 350 kilograms. How on earth does a 16 kilogram human on its own kill a 350 kilogram animal? It doesn't happen without social cooperation. So you can see here there was a very tricky question because what they asked you to do was make an inference. They asked you to infer that just because they had these big animals in their fire pits, that meant that they must have cooperated to get them there. So it's not just about recall in these questions, girls. You've got to think laterally. You've got to think logically as well to try and get through to the answer. So the fossils of Homo floresiensis show that they had opposable thumbs. So the development of opposable thumb in primate evolution. Does the opposable thumb distinguish Homo from other great apes? No, because all primates have it. Sorry, I should let you finish off this question. So I'm going to go through it in 3, 2, 1. So hopefully you paused. So was a necessary step in the development of bipedalism. Do you think having an opposable thumb means that you are also bipedal? Think about monkeys? No. It was an important anatomical development that assisted tool making in hominins. I can see this being really beneficial in being able to either use and also create tools. Yeah, I can't use a pen without this, so I'm going to leave that one there for a minute. Is a significant factor in determining the arm to leg ratio in modern humans. No, I don't think it's got anything to do with that. So my best answer there was the fact that it assisted in tool making. All right, so the development of bipedalism, this is the last question, this is on page 19. The development of bipedalism in hominins is believed to have a very significant effect on human evolution. Describe 2 effects of bipedalism on human behavior. So I want you to pause, and I'm going to go through it in 3, 2, 1. All right, so hopefully we were coming at what are some of the effects of bipedalism? What can bipedalism allow humans to do? So it freed our hands for tool making. It also freed our hands for carrying babies around so we could protect them better. It allowed us to reach higher food. It allowed us to scan for predators. You could get one of these, you couldn't get both of those. And the last thing is maybe it was just used for ceremony. So maybe it was used for dancing, communicating. Now, all of these things are really helpful in hominin evolution. So the effects needed to relate to behavior. So some of them referred to physiological effects. So the tilting of the pelvis, for example, to allow for bipedalism, that's not what the question asked. The question asked, what is an effect? So what does bipedalism allow us to do? So hopefully that helped you a little bit, and we're up to almost the very end of the course.